Right. In this example, we're given blocks A and B. They're having masses of MA and B and are initially moving to the right and left, respectively, on a smooth horizontal surface with speed of VA1 and VB1. And at some instant in time, A strikes B, and the coefficient of restitution of this impact is E. As a result, the impact block block B becomes stationary. So we need to determine what is the initial speed VB1 of the block B. Okay, now in order to solve this impact problem, first thing we want to do is to determine the coordinate system. Remember, now we have different coordinate system. That's an T coordinate system. So define the direction for N and T. In this case, we have two blocks impact with each other. So our coordinate system would have the plane of contact should be on this direction. This is T, and the line of impact is perpendicular to the plane of contact, right? So it's on this direction. This is N. Okay, once we have our coordinate system set up, we can start by looking at just one particle. Let's look at A first. Only look at A, and there's contact force in N direction, but there's no sum of forces on T direction, and then we can use the conservation of momentum on T direction. That will give us MA VAT2 equals MA VAT1. And since VAT2 T2 equals VAT1, both equal to 0. Why? Since T is this vertical direction, but however, if you look at this problem, all the motions are on N direction only. Therefore, we don't have VAT2 and VAT1. And the second step, we can take a look at particle B. So the conservation on T direction tells us MB VB2 equals MB VBT2. And same thing, we don't have motion on T direction. That's why VBT2 equals VBT1 equals 0. Okay, the third step is looking at A and B together. A plus B. Then if you look at A and B as a whole system, we can find the conservation of momentum on N direction, right? So we can write M A V A N2 plus B V A V B N2. That equals A V A N1 plus B V B N1. And so now if you look at all the velocities, speed in this equation, we have AN2, BN2, VN1, VBN1, and they're both on N direction. If you look at how we set up our coordinate system, N direction, it's the direction of the motion, right? And we know this, VN1, that's given, and we try to solve this, what is VBN1. But after the impact, B is stationary, so VBN2, that term goes to 0. So we know those informations. We can substitute 0 for baby n2 to get rid of the term. And we end up with ma va n2 equals to ma va n1 plus b va b n1. Okay, the fourth step we can take is to use the e equals 0.4 in this example. It's the coefficient of restitution, and the definition of e is e equals negative v b n2 minus v a n2. And on the bottom we have v b n1 minus v a n1. And we can get rid of the zero terms. As we know, v n2 is 0, so it's equal to negative v a n2 v b, v b n1 minus v a n1. Okay, so that will give us another equation. Since we know what is e, right, we can write v a n2 as a function of in terms of e. So v a n2 equals e times v b n1 minus v a n1. Okay, and always keep that in mind. VB1 n1 is something we're trying to solve, and we can call this equation 3, equation number 3, and we can call the equation we get from step 3, this equation, as equation 1. And we can substitute 3 into equation 1 and solve for VB1. Right, substitute VA into this equation 1, and we can solve the VBN1. So let's do that. Then in that case, we have MA, substitute VAN1, that's E times VBN1 minus VAN1 goes to MA VAN1 plus MB VBN1. Then if you look at this equation here, VBN1 and VBN1 is something we're trying to solve, and this VAN1 and VAN1, it's given the initial speed of VA. Okay, then we can put all the VBN1 on one side of the equation. That will give us VBN1 equals VAN1 times MA times 1 plus E, where A E minus MB over MA. And we can simplify this to get expression for AA VAN1 times 1 plus E over E minus MB over MA. Okay, so this is the final expression for VBN1. We can substitute VN1 and E and B and A into the equation. Then you end up with B VBN1, which is VB1, what we need to find, equals negative 1.91 meter per second. Okay, this is the answer to this problem. And the direction, so to the left.